I have the pleasure to present Joanna Wolszczak-Derlacz, sorry for the pronunciation, from the University of Technology of Gdańsk, who has a long experience in working on higher education analysis, efficiency analysis, and will deal with a very important topic, addressing knowledge creation and technological knowledge creation by European higher education institutions. And as I think Joanna will explain, there is a substantive issue, of course, analyzing, but there are also methodological issues in producing patent data clean enough, which can be combined with data from the European Tertiary Education Register. So the seminar will have both a methodological and a substantive dimension. And I'm happy to welcome Henning Kroll and Peter Neuhäusler from Fraunhofer, who are well-reputed experts of patent data, patent analysis, knowledge creation, and will give us feedback on the paper. As usual, first, Joanna will present your paper. I ask you to stay within 30-35 minutes, if possible, so that we have space for discussion and then for a general discussion. Please mute your micros if you are not talking. You can ask questions raising hand, writing in the chat, or during the general discussion, just opening your micro and camera. We like seeing faces of people, which is more encouraging also for the presenter. So if you are not eating a sandwich or drinking a beer, then keep your camera open, which will be appreciated. With all this, and thanking Manfred Payer and Serena Fabrizio and Rita Giuffredi for the perfect organization, I would like to give the word to Joanna.
Hello, I will share the screen. Yes. Can you see the full screen?
Yes. Yes, perfect.
Okay, so the paper is, as you can see here, a couple of people. We are all from Gdańsk University of Technology, Poland. I'm the last person here, okay? And this is the co-work with Aleksandra Parteka, Piotr Płatkowski, and Sabina Szymczak. In fact, as Benedetto noticed, there are many methodological problems. And in fact, when I will explain you how we merge data about patents with ether data about individual characteristic of universities, I think that we spent more than half a year for the construction of these data sets. Okay, so the value added of this paper is construction of the database on knowledge creation by university. Then I will tell you some stylized facts of the university patenting in Europe. And at the end, the basic empirical analysis about the impacts of different individual characteristics on universities on patenting activity. So patenting activity is well known as a proxy for innovation and new knowledge creation. And patents can be created by firms, university, research institution, and both as a joint effort of firms and university which work together. But according to the European Patent Office in 2024, only 7% of European patents were filed by universities. The majority is by large companies, 73%, and 20% by small, medium enterprises and individual inventors. And approximately based on patent RISIS data, 7% of all patents are jointly filed by firms and universities. So over 70% of European universities, they do not patent at all. Top 50 patenting universities in the world are 18 are from US, 18 from China, only 2 from Europe, Oxford, Imperial College of London. So in the literature, it is known this limited. So at one hand, we have high scientific research conducted by European universities, but the link between universities and industries to invent patents is very limited if we compare it to the US or China. So in the literature, it is known as European University Paradox. So what is the data that we have? So this is the micro-level database on knowledge creation by higher education institution. And we have two samples. One sample is over the years 1980-2019. We have 866 patenting universities from 31 European countries. And the second sample, when we merge the patenting and non-patenting universities from PatStat to ETHER, and this is the limited period of time from 2011-2019. The limitation is based on the availability of ETHER database. Here you see the map of the 866 patenting universities from 31 countries. As you can see here, 90% is from Germany, 18% from France, and 13% from the UK. Here, about the sample 2, where we have 785 patenting and 2,101 non-patenting universities. Again, you see the map where they are located, and non-patenting universities, we base it on the free databases if there is no patent in PatStat, in ORREC or RISIS patents. Okay, so data source. So we have university patent records with European application in PatStat. In PatStat, there is the variable, the indicator of the sector of the patent, and we limit the data to the university, hospital university, and university company. So it is our base data. Then we have data about citation and patent quality indicators from OECD. Then, as said before, we merged it with European Tertiary Education Register. We have information from RISIS patents, and we have data about artificial intelligence index. So we know the AI, if the patent is classified as AI patent. And we also have the information at the NUTS2 level about the regional statistics, like the share of research employment in research or in higher education. Of course, some basic like GDP per capita and other statistics. So identification of universities in patents is highly problematic, and it is similar to the problems when we want to merge PatStat with film level studies, for example, from Amadeus or Orbis. So then we have the identification of the unit, and actually it can refer many units can refer to one university. Here you have the example, Federal University of Technology, Zurich, or Trinity College, Dublin, is described by even 80 or more different IDs and names in PatStat. So our contribution is the crosswalk between PatStat and ETHER. So what we have done at the very beginning, we merge the country and NUTS2 levels from those two sources. And when we have the same NUTS2, then we run the algorithm of Levenstein distance. And then, so this is the algorithm that check the similarity between two different words. So we have the name of the university from PatStat and the name from ETHER. Then we treat, if the similarity ratio is over 85%, we treat it as the same university. But for the similarity ratio between 45% and 85%, we do the complex manual checks. As I told you, so this crosswalk was the milestone of our research, and we spent, as I told you, a couple of months to done it. At the end, we have a unique correspondence between the ID from PATSTAT and the ETHER ID for 1,068 universities. And the overall success rate in matching PATSTAT and ETHER is 87%. Now I will show you a couple of statistics considering patenting in Europe, time trends, country ranking, distribution across higher education institution, distribution by regions, patent counts, and patent citation. Here you see the time trend. The patent application are fractional apportionment. Here you see the increase in the patent application, all application, and also granted patents. The drop in granted patents at the end is due to the PATSTAT release that we have. Okay, so it's probably then the trend will be upward. Here you see the ranking of countries, top 5 in green. So as you can see here, top countries are United Kingdom, Germany, France, Switzerland, and Belgium. For example, Poland is on the 12th place. And as I told you, we have 31 European countries. And you have ranking according to all patents application and according to granted patents. And the ranking is similar for those two specifications. Here you see the map of top 100 European patented universities. Here you see total number of granted patents and all patents application. This is from 5 patent offices. So this is the data, this sample 1, data from 1980 to 2012. Sometimes you see, for example, London, there is a big circle, meaning that there are more than one university, patenting university. Here you see the distribution across regions, top regions, left side of patent application, and citation on the right-hand side, again, based on the sample 1. So as you can see here, there is the clear core periphery model of the distribution of patents and citation. The red means more patents. Sometimes we have no data for some of the countries. Here the characteristics of patenting versus non-patenting universities. We divide the sample into all sample of universities and also characteristic by the STEM disciplines. The STEM is defined as the ratio of the students or graduates from the STEM disciplines to total students. If the ratio is bigger than 1%, we consider the university as the STEM university. So as you can see here, we have the patenting, it's 785 universities, and then non-patenting 2,101. When we have the STEM universities, the ratio of patenting to non-patenting is bigger, is around 50%. The first is foundation year, the first characteristic of university. Of course, it is based on the sample 2. So this is this PATSTAT match with ETHER. So foundation year, as you can see here, the patenting universities are older than non-patenting. It is true for all sample and for the STEM universities. Total number of academic staff and total number of students, which can be proxy of the size. As you can see here, patenting universities are much more bigger. Students per academic staff, which can be proxy of teaching load, is higher for the non-patenting universities than for the patenting ones. Graduate per academic staff, the same, bigger for the non-patenting universities. And then research orientation, publication per academic staff, number of publication, this is the publication indexes in Web of Science. So the ratio, as you can see here, is bigger for patenting than for non-patenting. Total revenues and revenues per academic staff, as you can see here, patenting universities, higher education institutions are much more richer than non-patenting. Then we have the definition, the classification of revenues coming from so-called core revenues defined in Ether as those money that are mostly directed from the public sources, not for the distinct activity, but total to the university. And as you can see here, it is a bit higher for the patenting universities than non-patenting. And third-party revenues to total budget, it's higher for the patenting than for non-patenting universities. Then we run easy the second part, considering the impact of the individual characteristic of universities on the patenting. So in the previous literature, there are a couple of determinants that impact the patenting activities of higher education institutions. First of all, there is discussion about the link between publication and patenting. And the link can be positive or negative. There is no agreement in the previous studies. It depends on the country, on the time period of the analysis. So the idea is that professors or individuals who work at the higher education institution, whether if they publish more, they patent more, or maybe then be converse relationship. Then we have funding and structure, which impact the patenting activities, public versus private funding. Usually public universities patent more. We have internal and external funding coming from, for example, industries or research agencies. Usually the external funding is connected more with patenting. Then institution support, law and regulation, which also impact the patenting and patenting activities. University type, private versus public, with and without, for example, medical school. Those with medical school, of course, patent more. Research situation and individual motivation, age, seniority, position, usually more senior and with higher position individuals patent more. Then regional influence. There are some studies, for example, based on the Italian data, and we see the regional distribution of patenting. Although there is the discussion what is the cause and what is the effect, meaning whether regional characteristic impact the patenting or vice versa, whether patenting impact regional characteristic. And then there are just a few studies showing the multi-factor determinants of the patenting. So they take into account simultaneously different factors that might impact the patenting activity. And based on these previous studies and data that we have, we ran this simple model. On the left-hand side, we have the patents or quality of patents. On the right-hand side, we have the number of students as the proxy of size, year or foundation, students per academic staff, publication per academic staff, revenues per academic staff, third-party budget, core budget. Then we have the time dummies, country dummies, and sorry, there is a mistake because we have also NUTS2 dummies, taking into account the different regional characteristic of the Europe and the European level. So I is individual university, time is time period. And here the estimation results, determinants of university patenting. So the dependent variable is the number of patent application coming from 5 patent offices, fractional apportionment. We use the share and the applicant share, and CPS, so sectoral, so the characteristic of the patent fractional count. So as you can see here, there is the foundation. So older universities, they patent more. Bigger universities, log of students, patent more. Students per academic staff, so it is inverse relationship. So students per academic staff are negatively correlated with the patenting activity. Publication per academic staff, it is positively correlated with the patenting activities. Revenues per academic staff is positively correlated with patenting, meaning that richer university patent more. Core budget is negatively correlated with the patenting activities. So universities with higher share of core in relation to third party, they patent less, but when we take simultaneously, it loses its statistical significance, and third party is positively correlated with the patenting activity. As you can see here, there is different number of observation depending on the number of independent variables that we take into account, because the data on the revenues, there is, as you can see here, there is a drop to 24 countries, and when we have all variables, 23 countries. Usually, so there is many missing observation considering the financial aspect of the university. In second, here it is not shown, but we also add as a robustness check, we add the STEM indicator. It is positively correlated with patenting, which is reasonable. And we also take the number of EU programs that university take part, that participate in how many EU programs, and it is positively correlated with the patenting activities. And conclusion, so this is the creation of new data sets on universities and knowledge creation available for research. So this is the merge of the PATSAT with Ether crosswalk. So we document the increase in universities patents since 1990, but there is rather low role of universities in European system of knowledge creation. There is strong core periphery patterns of university patenting. 5 countries are responsible for over 70% of all patents application. Over 70% of European universities do not patent at all. There are big players from the UK, Germany, Switzerland, France, which dominate the patenting activities in Europe. Bigger order, more research-orientated, measured by the publication with a higher proportion of third-party budget are more likely to patent. Conversely, the higher the number of students per academic staff, the higher the probability of no patenting, the same with core budget. And there are many possible extensions of the data sets that we constructed. We have the information about the characteristic of patents. We have the indicator whether the patent is AI. And we have then from the OECD database, we have the information about the number of quality indicators for backward, forward, breakthrough, etc. And some limitation. This is the limited sample of universities from the limited time period, in fact. The possible extension can be also the analysis for the single country, for example, especially the big countries like the UK, Germany, Poland, Italy, where there is this the distribution of the patenting universities is noticeable, because there are different regulation considering, first of all, the activity of universities per se, or the different regulation considering patenting activity. What we have done so far, we introduced the country fixed effect. Maybe it is worthwhile, or maybe not maybe, but for sure it is it would be profitable to include information on the different regulation. And that's for me. Thank you very much for the attention. If you have any question afterwards, you can contact me directly. One more thing, at the moment, the publication is under review. If it will be published, we will provide freely the crosswalk between PATSTAT and ETHER, the replication packages, what we have done. One thing that we cannot provide, because data from PATSTAT is a commercial source, so we cannot provide the data from PATSTAT, but we can provide the crosswalk between PATSTAT and ETHER. So thank you for your attention, and I'm looking forward for the discussion.
Thank you, Joanna, for this very interesting presentation and nice work. I would like to give the word directly to Henning for his rejoinder and comments.
Yeah, thank you very much, Benedetto. Thanks for having me. Can you hear me loud and clear?
Yes,
yes, we can hear you.
That is perfect, and thanks to German Rail Services for bringing me here in time for once. That's very good.
That's exceptional.
Yeah, that's exceptional these days. Yeah, they're getting better slightly though. I have with me also Peter Neuhäusler here, who's probably even a bit more into the matter than I am on university patents and all that here within the department. So I thought that'd be good if we are both here today, in case there are any particular follow-up questions. First of all, Joanna, regarding your presentation, thank you very much. Very timely, very interesting, very clearly explained. So I kind of find hard pressed even to put forward all the positive points. I think it's a very relevant subject to look into that in more detail, and for that it is very valuable to have that matching. We know how to set apart universities and patenting generally for a long time, but we can typically only do that for universities institution by institution for particular countries. So being now able to do that across the entirety of Europe is certainly very helpful. The integration of the different IDs into PATSTAT, this is probably methodologically very important and also relevant step to take to make this analysis sound. Also, all the figures that I looked at, I found plausible. There's nothing that I would necessarily want to question. And the particular this analysis of patenting versus non-patenting universities, I think this is also from a policy point of view a very important angle to take to see who's doing what potentially further down the line, also in what fields, and on what does that depend. So overall, very solid, very clear. In terms of room for improvement, I think I'd like to start from the angle of kind of connecting to what I just said. you're building on something that already exists. And on your first slides, when you go into this, you kind of, with your first descriptive finding, you mix the old with the new, and sometimes it doesn't necessarily become clear what is the essential added value of what we've produced here. And for example, we all know that universities have a smaller part in the overall patenting portfolio of a given national innovation system. We've been knowing that since gut feeling probably since the 1950s, and we're being able to show that empirically since the 1990s, early 2000s. So that is not new. What is new, for example, is that you have these precise numbers on patenting universities and non-patenting universities and their structures. So there's huge added value there. And maybe if that would be set apart a bit clearer, and would make for an even better introduction in the future. Overall, to that end, I think you could also, I mean, possibly not in this round here, but if you take this outside, elaborate on ITER a bit more. I mean, this is not necessarily, we don't misspell a fusion reactor here. It's a project with its own characteristics, heritage of UMIDA, as it were. So there's a lot of things behind there, what ITER is and ITER means and why it is important to integrate it here. Maybe we could in the future spend a bit more time on that, and that also subsequently would make it clearer to the less informed observer why that is relevant, what we are doing here. Second point would be a bit more analytical, maybe. I think I share all your considerations concerning the independent variables, like, okay, these are the things that we should be checking for to explain why they patent more or less, or they do that or not at all. Again, that is relatively quickly introduced. I mean, if I looked at it longer when I first saw the slides, I saw some conceptual groups there of things that we would want to look at, and then we have different indicators reflecting those. And maybe for future presentation also that could be made clearer. Why do we look at the individual independent variables? What larger argument are we trying to make here? What more general characteristic of universities are we trying to look at here, and what general argument are we trying to make? What is important for their patenting behavior or not? So for example, we look at students per staff, so that is about teaching load. So we're talking about how the overall orientation of the universities in terms of strategy probably matters for the patent behavior. So we take students per staff as a proxy to look at that. And then I think this overall framing could in the future be made. It's all there in substance, and then the results also convince me. But in principle, I think this could possibly be sold a bit better. On the figures that we are looking at, some technical things, some things in terms of more conceptual framing. I think one very fundamental thing, if we look at things and try to explain them, is that we all know that the inclination of professors at universities depends on the legal to patent. Their inclination to patent depends on the legal framework. So people would necessarily behave differently depending on whether they have a professor's privilege or not. And that, of course, affects the numbers that we are looking at. And Peter Neuhäusler has just done a new project or a recent project that again does that for the EPO to demonstrate in more detail which countries patent to what degree through this official channel of patents that we can map back to universities directly. So if we compare cross-national, I think that's an important point, at least to mention in any presentation we do on that we would expect to see different figures. We would also, if we do an absolute ranking, we would expect to see different absolute numbers, not only because of university size, but also because of these secondary reasons. For that reason, I would probably also like to suggest that if you develop that presentation further, I think this absolute ranking is very valuable. It's very interesting to see just face value, which institutions patent most within Europe. But then I think the relative values would also be highly interesting to see. Well, what is the share of universities that we can thus identify in the national patenting system in France as compared to Belgium or as compared to Austria, and what does that mean? So I think the what does that mean and what patents are we seeing questions are typically better served if we look into relative figures than into absolute figures, and that would probably be something to do in the future also if we kind of go into the area of comparing patenting universities to non-patenting universities. That will also there play a role. I have a few minor technical points also. I mean, I've been wondering a bit why you're going back to 1980 and in the timeline, which possibly raises more methodological questions than it answers. I think if you can do that, if you're really confident that all the databases are safe and sound back until 1980s that you're working with, then that's probably a thing. That's something that I cannot really check remotely. From what I know about these databases, I would have a few doubts. So I would probably consider just going back to 1990 or even 2000, because based on even what we see there, we can tell sufficiently interesting stories, and we could just say, okay, it's a phenomenon that's relatively recent. And before that, there wasn't that much of activity. Maybe just present a few aggregate figures. What else do I have? Well, cartography. I'm a geographer by training. Please don't put absolute numbers into areas. Just makes the eyes of several people hurt who've been trained in the field. Will be better to work through symbols, but that's a mere matter of presentation. It's sometimes confusing if you have very big and small areas. Sometimes look at that. It's kind of hard to understand. Overall, I think that is pretty much it. Again, I like the piece. I think that it's very valuable. The overall framing in terms of what is the start. I mean, for the time being, this is a RISIS presentation. We present the data set, we validate the data set. That's all fine. If we were to take that into future articles, I think the overall story in terms of the arguments and the priors that we are putting forward could be yet a bit clearer, and that probably will be the next step to work on. And I wish you good luck with that. Thanks for having me here today, and looking forward to the presentation.
Okay,
Thank you, Henning. Joanna, would you like to give a short reply, and then we open the discussion?
Thank you, Henning, for your comments. And about the ether data, I didn't say more details because we have experts here, so probably everybody knows. And Benedetto put also the link on the chat to ether data. That's why I didn't spend much more time on it. And then we'll try to take into account all your suggestion. Okay, the biggest problem is that we have these 31 countries, European countries, and they have different regulation, considering the patent activities, especially considering the patent activities by universities. For example, this different regulation and different law. So mainly we think in future studies to focus on, for example, main, I don't know, 5 for the limited number of countries to look inside what's going on, because then we will be sure that the law is the same. And then we have characteristic of NUTS2 level at the NUTS2 level, so we can take into account the regional characteristic and maybe to run some regional statistic considering the patent activities. Anyway, thank you for all your comments, okay, and that you have been discussant. And so now maybe the open.
Yes, thank you. As you saw, I put in the chat the link to the ETHER database, but also the paper we published in Nature Scientific Data, which is the reference on ETHER, where there is very detailed information. I have myself made some comments, but I would like to open first the floor for other comments or questions.
Benedetto, may I ask a question?
Yes, yes, Emanuela.
Thank you. Good morning, Emanuela Reale from the National Research Council Research Institute on Sustainable Economic Growth. Many thanks for your presentation. Very interesting, very good work done with the data. I think it's a nice result, what you present, but I have 2 comments. questions, let's say. First, you spoke always about universities as a whole, but we know that patenting is extremely concentrated in few fields. So are you able to explore the way in which the comparison between your patenting and non-patenting universities are more or less linked to some specific fields, the dimension and characteristics in terms of publishing? That's the first problem. The second item I want to ask is, in the list of the main literature on university patenting, I don't find any reference to the bulk of literature about academic patenting linked to the hidden patenting in universities, meaning that what you have as a result of patents registered, granted at universities, are only a very small part of the university efforts toward patenting. This was as largely demonstrated by works by Lissoni, Breschi, Crispi, and so on, but several other authors as well. So I wonder if it is a limitation, natural limitation of your study, or if you have some capabilities to go inside this kind of phenomenon. Thank you.
Thank you for questions. In fact, so the second point, yes, this is the limitation of database. We have just information about the registered, the patents. We don't have information about the hidden patents. For example, if there is a professor that patents something, but on the individual level, not at the university, do not provide the university affiliation, we cannot see this. Yes. And the first question about the references, we mainly focuses not on the characteristic of academicians, but on the characteristics of universities that that we have into account. But thank you for providing the references. Of course, we will take them into account. Thank you very much.
Yes, thank you. On the first point, I would like to give back the word to Henning and Peter Neuhäusler, since ISI Fraunhofer is been working on systematizing the data on academic patents, and I can announce that the next year, thanks to their work, we will have academic patents in ETHER and ESO, but probably you can tell us more on the differences you found.
Yeah, Peter, maybe you go first.
Yeah. Would have also been my question. That was the obvious one, whether you use university filed or academic patents. So we are currently, or we've been working with the EPO on a study on academic patenting, and there will be an event on October 22nd, which is next week, where the EPO results will be published also. Where we have analyzed academic patents in more detail, which includes not only university filed, but also the university invented patents, exactly the ones you were referring to, Emanuela, just before. Benedetto, we've also discussed this matter, and let's see how we can share the data in the future, so we can come up with additional studies here, digging deeper into the data that is available.
Okay, thank you. And on my side, I have a question to Joanna. When we did the exercise with PatStat on patents filed by universities in Paris, there were some cases of institutions which we for sure knew they should patent, and we couldn't not find, probably because either all patents are academic but owned by companies, or because there are subsidiaries, which happens in some cases in the UK. So, for example, we had lots of problems with Swedish university. Did you make a check if there are clearly missing universities in your patent data? Because you track quickly by looking to size and STEM specialization and research intensity.
No, in fact, we didn't look for this, but yeah, it would need probably manual check, yes, to see if the universities that should patent that they are not observing PATSTAT, yes.
Yeah, we identified them in a simple way. We did a regression like you did, and then the regression predicts number of patents for the whole sample. And then if the regression predicts 100 of 200 patents and you have 0, you start saying there are these cases. So you can use your regressions also to detect missing cases, actually. And we found lots of problems. Some we could solve, like some UK university was a subsidiary, but some remain mysterious as far as I remember.
Okay, maybe we can do this exercise.
Yeah, I suggest as a robustness, a reviewer might ask it.
And by the way, and maybe as a follow-up, we've also done the matching to ETA, and we are in a similar range of matching rates. So we are, depending on the office, somewhere between 86 and 91%. So your 87 or 89% sound pretty much like the coverage that we have. Anyway, just for the sake of completeness, it would be maybe nice to compare the results. So if you share yours, we might be able to share our matching and then have an added value of maybe a few percent on the coverage, which would make it even better. But we might talk about this in the future.
Okay, yes. Further question, I see Mark was a question or a comment.
Yeah, it's more like when I looked at the results, I was wondering if there's not an opportunity to even more compare the universities, because you have two groups now with no patenting and with patenting, but I think there must be differences within the group of patenting universities, and maybe it is fruitful to see those. I don't know, that was one idea with high patenting and lower patenting, and what does this mean, and to get into a little bit more detail, and yeah, that's one of the things. If you get more of a classification of patenting universities, something like this.
We done something different because as a robustness check, we ran the zero inflated beta model that divide the regression into 0, 1, patenting, non-patenting, and then the impact of the determinants for those that patent. And in fact, we found some differences. But maybe we can do what you suggest, to divide into highly patenting, for example, and low patenting. It can be also done. Thank you for the suggestion.
Yes, thank you. On my side, I would have still a couple of questions or comments on your results. First is why you introduce foundation year as your first variable. Because, you know, foundation year is correlated with everything, with size, with research intensity, with reputation, with etc. So in a way, I think in the model, you should have a substantive reasoning behind that variable and not just introducing it in that way. And similarly, I wonder why you focus so little on subject mix in the regression, because of course, what we expect is that subject composition is one of the major determinants of patenting, especially because in ITER we have a lot of institutions with a lot of social sciences. So why to present a regression and say, but by the way, we introduce also subject mix. It was significant. I would like to see the results and to see how it interacts. And maybe to see different variants, because subject mix might mean different things. So STEM is a broad range, science and engineering are different areas. And my final question, a bit more reviewer-like minded, what is really new in that result? So it's nice to see empirical results, but so in a way, probably everybody would expect that patenting growth with size measured in terms of academics, in terms of research intensity, in terms of publication intensity, is more oriented to STEM, etc. So it would be interesting to see some more flesh. So, for example, what is more important in these effects? Is subject composition more important than research orientation per se? Or so I would like to see something more than just what is now seems very confirmatory in a way of what you know. And I see Henning maybe that wants to follow on my comments.
Yeah, maybe to add there a bit. I mean, I see it the same way as I said before. We need a clearer reasoning on some parts. And secondly, I mean, unless we only do this for a particular country, I would only see two ways. And the first one would be that we effectively control for the regulatory differences. We put in a variable saying, okay, professor's privilege, yes or no, maybe country dummies to just take this out of the overall regression. Or we should beforehand kind of estimate the real world values. I mean, as Emanuela was saying, we are only seeing part of the iceberg here. And then it would be potentially misleading also if we follow Mark's suggestion to be even more differentiated in terms of the groups and types of universities that we are looking at. We cannot do that on just the top of the iceberg. Then we would either have to control very carefully, or we would have to do an estimation beforehand that adds the whatever 50% invisible that we typically see in country A, or leaves it as is in Turkey, because we know there's nothing much hidden in Turkey typically because they're forcing it. Things like that. I think these are the two ways we have to do. Otherwise, we have the problem that we may run into seeming observations that in the end are not substantive.
And if I add one important question would be, what about medicine? Because now we tend traditionally to identify patents with engineering, but we know that with biotech, medicine may be more important. It may raise also methodological problems because medicine is linked to university hospitals, and university hospitals tend to have their own legal entity, and then it might be that you lose the patents of medical schools.
Yeah, we simply have different propensities to patent also in different fields, both sectoral fields and academic fields, and that probably we should control for in a more differentiated manner.
Okay, so just answer the few questions that Benedetto proposed. With the foundation year, it's the feasibility of data. Yes, that for the foundation year we have the information for almost all universities. Okay, so it was just this reason that we put it in all specification. But we have to check the correlation between other variables. The subject mix, we include in the robustness check just the STEM identification. The problem is with the subject mix, it's that there are many missing observations at the ether data, considering the subject mix. So that's why we didn't include it into our regression. What we done.
Sorry, Joanna, what about using, so besides if you use students, there are less missings, but you could also use bibliometrics data, which match more to research.
Mm-hmm. So but what do you mean bibliometric data?
So publications by field.
Publication per field, yes.
So this would be an alternative, and I think a reviewer might ask why you don't use publications which tend to reflect more the research effort than of course, students. And of course, now the data are mostly readily available, at least for the core of patenting universities. You can download the data basically from the Leiden ranking or for any sources.
Mm-hmm. Okay, thank you.
Sorry, any other comments or questions? So I think we are definitely not only in an important area, but also in an area where we are making huge progress, because we start being able to track this landscape of patenting of universities, which was not very visible in the past. We start having alternative sources of data, so it will be very interesting to contrast academic patents and filed patents, for example, and to compare methodologies and data sources to get more robust matching and more robust data quality. So that's definitely something which is emerging around the presence of the data set. And I think one goal of these seminars is to put groups working on the same issues in contact, so that there is also methodological exchange and cooperation. And in the ETHER and the European Higher Education Sector Observatory, we intend to have patent data as much as possible at the university level, and to foster these kind of activities. And of course, also documenting methods like the crosswalk you develop for extracting data from patent. Are there any other comments or questions? If not, I suggest, or I'm kindly asking Rita to show the slide of the next seminar. We switch to a completely different topic, widely different topic, but which is equally of high importance for studying higher education systems in Europe, which is study of social selectivity and study flexibility. And on something we have been experimenting to combine data from the Euro student survey with institutional characteristics of universities in ETHER. That's an important issue about social stratification within higher education systems. So the fact that characteristics of students are not random depending on the type of universities, for example, and we expect better educated students, better off students socially to be concentrated, for example, in research universities. And the presentation will be by Hendrik Schirmer from DZW and discussant, a very well-known social scientist, Michael Gretz from University of Lausanne. So I really want first to thank Joanna, Henning, Peter, and the organizing team for today, and wish that you will be there for the next seminar in about 1 month. And wish you a nice afternoon.
Okay, thank you very much, Benedetto and organizers.
Thank you. Bye.
Thank you. Bye.
Thank you. Bye-bye.
Bye.
Bye-bye.
Bye-bye.